Hello, everyone. I'm Joe Pryweller, Conference Director for Tire Business. Welcome to this Ask the Expert session, your chance to engage with professionals on a range of topics and to interact with questions. Today's Ask the Expert is sponsored by BKT USA Inc. Our expert is Chris Rhoades, Senior Product Manager for Technology Solutions with BKT. Chris will walk us through BKT's technology in helping to select the most productive tire for your operations, utilizing best-in-industry technology. With many options to choose from, which tire should you select for your haul trucks? To submit a question, email tbevents@crane.com, or if you're watching along on LinkedIn, Facebook, or YouTube, submit your questions through those platforms. With that, I will turn things over to Chris Rhoades of BKT USA. Chris, take it away.
Thank you, Joe. And I want to thank Tire Business for this opportunity to present this information. My goal today is to highlight the processes that goes into selecting the most productive tire for your operation, if you're the customer or the dealer. Next slide, please. In order to do that, we want to make sure that we meet your goals. And first major goal is production. In order to achieve production goals, tires need to be able to aid your efforts and not be a limiting factor. We do need to identify the tire that will work with your operations' stated loads and speeds. We also want to avoid any unplanned downtime. We can do that by managing early tire failures due to cuts and heat. We also want to select a tire that provides you that achieve the longest life, which is the highest hours or miles achieved, which is, again, the best wearing tire. We also want to always keep the bottom line in mind and give you the best value of the tire. And this doesn't mean the cheapest tire. Cheapest doesn't necessarily translate into the best value. We do want to look at the lowest cost per hour or the total cost of ownership. But in order to meet these goals, we do need to follow a process. So next slide, please. So kind of an overview, we'll be talking through what a typical sales call will look like that's received. Go into what we would like to do is coming on site to do a visit. While we're on site, we would like to be able to perform a spot tech study, and more on that in a bit. We want to be able to use that visit and study to help select the right pattern and begin to calculate the operations TMPH value, which is a ton mile per hour value. That will help us select the right compound of the right pattern tire for you. And then ultimately, any tire presentation is not complete without talking about pressure. So we also want to give you an insight on how to calculate a good pressure recommendation. Next slide, please. So a typical phone call coming from a customer or even a dealer into a BKT person will be, hey, do you have any 2400 R35 tires in stock? We need some. And then the question quickly gets into, well, how much are they? So in order to best answer that question, we should ask more questions, right, from our side, because we need to make sure we select the right tire for you. And in BKT's product lineup, for the 2400 R35 tires, which are typically fitted on anywhere from about a 60 to 70 ton haul truck, we've got over 17 different SKUs across 5 patterns, multiple compounds, also some in a 3-star load rating as well. So of these tires, we want to be able to understand, do you need more of a rock pattern type, more of a traction pattern type? We want to know what type of compound. Do we need cut resistance here, or do we need a heat resistance, or somewhere in the middle of the road? So in order to be able to take this list and narrow it down, we're going to ask a few extra questions. So next slide, please. And one of the first generic questions is, what are these tires being mounted on? Here are 4 typical haul trucks that all take 24R35, 2 from Komatsu, 2 from Caterpillar. And if you'll look across the top, you see both Komatsu and Cat have around a 61-ton payload carrying capacity haul truck, and on the bottom going all the way up to right around average of 70 tons. So which truck these tires will be mounted on and the rest of your fleet will go into calculating which tire we need to have. So next slide, please. Once we know what the fleet looks like, our desire will be able to come do an on-site visit. We'll want to come on site, send a team or even an individual engineer. And one of the first things we'll want to do is meet with management. Whether it be the plant manager, or if the mine's big enough, even the production manager, maintenance manager, or if they have a tire program manager, them. We'll want to be able to know what their operating hours are. How many hours per shift are they running? What are the longest haul distances? Are there any mine planning changes coming up? Are they going to expand to a longer haul in the future? What are the existing challenges or issues they're experiencing in their tire program so that we can see to aid in doing that? What type of tire performance are they achieving already so that if we come in there, we can look to meet or exceed the current expectations? After the conversations are done, one of the things we'll want to do is do a job condition report. We'll want to drive along, look at the operation. We'll want to look at the loading areas, dumping areas. We'll look at just the general haul road conditions. And just keep an eye for spillage, tight corners, grades, everything that could impact the tire's life. We'd also like to spend some time on a scrap pile to see tires that have already ran there and come out of service. What are we noticing? What stories are they telling us about the operation? If time permitting, we'd like to do an inspection of the current fleet to see what tires are running and the shape that they're in and see what stories they tell. While we're doing all of this hands-on, and before we start any of that, we'd like to go ahead and install a spot tech. So the study is going while we're doing all this other. So what is a spot tech study? Next slide, please. Spot tech stands for Satellite Performance Optimization Technology. It's a GPS and G-force-based study that we put a camera. If you look at the truck on the right, we'll install a GPS antenna, a data logger that's got a 3-axis accelerometer for G-forces, also a camera, and we will be able to combine all that data together. It's a quick install, takes less than 5 minutes to put on the truck and even less to take off. And we'll even arrive before the shift while the truck's on the ready line so we don't have any extra downtime. Our goal will be collected at least minimally about a shift's worth of data. And then the outputs, we'll have a video that we'll show you shortly. We'll be able to map the haul roads, analyze during a study. We'll be able to get cycle times of how quickly the trucks can do a full lap. That'll give us speeds. The speeds will help us go into calculating the TMPH for the operation. And we can also look at some cornering and overall productivity enhancements as well. So what we're getting ready to look at is just an abbreviated high-level look of what a spot tech presentation study results would look like. So next slide, please. One of the outputs will be a video overlaid with the data being generated from the study. And one of the first things we'll want to do is sit down with the mine management and go on a ride along with the operator for a typical cycle. On the right-hand side, you can see a speedometer to see what the speed is at any given point in the time. You will have the vertical red bar going up and down. This will be vertical forces that will peak if you see some undulations on the road or potholes. And then you have the side-to-side numbers. As we're going through this corner, you'll see the lateral forces go up to about 0.23, 0.24 right now. And on the green, it's actually following the truck along the haul road path. So this will be able to allow us to be able to almost do a virtual job condition report together so that we can see different points and bring it out together before we look at the actual data. Again, a picture's worth 1,000 words. Video of your operation with some data is worth a lot more. Next slide, please. One of the next things we're going to take a look at is actually that all the data is recorded. So on the left, you see like a satellite imagery of the haul road that's mapped of the study. We'll mark out any of the loading areas and dumping areas. And in some cases, there's more than one of each. And the data we're showing here is just, like I said, abbreviated study for sample size, but we would like more time, more distance, and more cycles done. But in this case, there were 5 total cycles for 1 hour and 40 minutes, and the truck traveled a total of 15 miles. We want to take a look at what your fastest cycle time and the fastest speed is. as well as the average. The average will actually go that 9.4 miles per hour in the middle of the screen. That will go towards our TMPH calculation. We also want to look at the individual laps as well to make sure there's no outliers, that if everything's looking pretty consistent, the data seems okay. And if there's anything that looks out of the ordinary, we go back in the video and be able to see what's going on there to explain that. Next slide, please. When it comes to the G-force measurement, the 24R35 tire, it's rated to carry 40,800 pounds at 102 PSI. So if you look at the TRA books or any tire manufacturer's data books, if you look at 24R35 tire, and if you look at the load and inflation tables at 102 PSI, if you go down, you'll see 40,800 pounds. This is at 1G Earth's gravity. And what will happen is if the G forces on the road, if you have a lot of potholes and or undulations, you're going to get a lot more up and down flexing of the tire, which can increase the heat buildup. Then we switch over to looking at lateral forces. As the trucks are going around the corner, you're throwing forces into the side of the tire. And we're targeting to not have anything more of a max of 0.2 Gs, which would translate to about an extra 8,200 pounds of force being thrown into the side of the tire, specifically around the Schaefer area and the belt edge. And that belt edge area is going to be important in a second, because not only will corners impact extra forces there, that's also going to be a big flex point and a heat buildup point when we start talking TMPH. Next slide, please. So we take a look at a typical road and we look at all the lateral forces happening. And in this study, we identified 2 corners that we need to take further look at. So corner A had a max lateral force of 0.19, duration for 5 seconds. It's about a 15.7 meter corner radius. And we can also monitor what the speeds are into the corners, average and leaving, because what causes high lateral forces will be the corner radius. Is it a tight turn or not? Is there banking and elevation of the turn, and the speed? So worst case is going fast into a reverse banked curve that's really tight. So we got 3 variables we can play with to straighten that out to reduce the forces. So this is just a high level view of the spot tech. There's more slides, more information, and more recommendations in for one, but just to show you some of the data that we would gather while we're on site. Next slide, please. All of the data from the observational data and the spot tech data will give us data to go into calculating the operational TMPH. Part of the discussions also is we're going to be working, for the sake of this presentation, book values from Caterpillar and the values we got from Spot Tech. We do want to look at onboard scales. We can look at dispatch data. We would definitely want to have more accurate long-term information from the mine site itself, because the Spot Tech is a single study. But TMPH, simply defined, is ton mile per hour. And to calculate that, we do want to calculate the average tire load. And when I say average, we want to look at how much that tire is carrying on an average day. So we need to look at when the truck is empty, also when the truck is full, and divide that by 2. And we're looking at a load per tire. So we're going to look at a specific tire, not the overall, all 6 tires. And then we're also going to look at an average work shift speed. So the average work shift speed is, again, the average speed that that truck goes for the whole shift. Now, that's not just moving or top speed. That also includes in sitting while the truck is being loaded and dumping. So we're going to look at the, again, what's the total shift time and how far that truck has traveled to calculate that. And TMPH is a measure of work capacity. So an operation desires this truck to carry a certain amount of load at a certain amount of speed. And we need to make sure that the tire selected has a rating that is greater than the operational TMPH. So the tire's TMPH rating should be higher than the operational TMPH measured. Excess heat buildup leads to tire failures and heat separations. We need to take a look at some other factors. So how do we now take this concept and start doing a quick look at how we actually calculate this? Next slide, please. So one of the things we have to first do before getting the calculation is understand a couple design principles. Tires don't carry the load of the vehicle. The air pressure inside the tires do. That's why we say that a tire, 24R35, can carry 100 or 40,800 pounds at 102 psi. If you need to carry more load, you need to increase the air pressure to carry that load. If you have less load, you can decrease the air pressure. And the reason is because we design our tires to TRA specs per the middle graphic that under a given load and in pressure, our tire has a certain design characteristic. So we design flex points, we design certain dimensions that as a tire rolls, we have a certain footprint, etc. As the tire goes through its revolution and flexes, heat is generated and built up, and the hot spot is right at the belt edge on the third graphic. So this belt edge is where tires, again, become the hottest. And as you'll remember a couple slides back, that's also where the lateral forces will also hit a tire. So between the spot tech and the TMPH calculations, these become important in knowing which tire to push to the limits. Next slide. So now the tire is in action. So this tire has a certain load on it, and that generates a certain footprint, which is we're generating heat. And the load and under air pressure will give you a certain amount of deflection on the tire that we want to calculate from the factory. And again, you add more load to that tire will naturally squat more and deflect more. And the bigger the load, the louder and the bigger the amplitude on flex will be. So that amplitude, that deflection is part of the T, the load, the tons on the TMPH calculation. And on the right-hand side, you have velocity. So the faster that tire rotates, the more times it's going to flex in a given time period. So again, faster velocity, faster frequency, faster speed is more miles per hour. It's going to be the more times that goes. So in order to heat a tire up, we all know if you overload a tire and drive it really fast, we can build up heat. So how do you reduce heat? Again, it's a matter of taking off load or slowing down. But we always want to try to understand the customer has a desired speed and load in mind, and we need to select the right tire that can handle that. So next slide, please. Across these 4 trucks, you can see that they all have different target gross machine weights ranging from 226,000 pounds all the way to 252. So that's about a 26,000 pound difference on the end vehicle weight, all for the same tire. Payloads range. And even if you look at the load per tire, once it's full, you range anywhere from about 38,790 pounds all up to 41,905. So the same tire will experience different loads based upon what truck it's mounted on and what payloads are on there. Next slide, please. To take the 775G, we want to look at the average tire load. So we want to look at the tire load empty and the tire load loaded divided by 2 to get this average. And in this case, to get to the per tire, the empty operating weight on this truck is 110,000 pounds. But that 110,000 pounds is 50% on the front axle, 50% on the rear. So you'd want to multiply the 110,000 by 50% and then divide by 2 to get a single tire. And the same is true on the loaded side. The loaded truck weighs 246,500 pounds. And that load goes in the rear, which shifts the weight distribution instead of 50-50 to 34% of the weight is now on the front axle, 66 is on the rear. So you need to multiply the 246,000 by 0.34 to get that percent on that axle and divide that by 2. Add those two numbers together, divide by 2, and then divide 2,000. That will give you your T for the TMPH in short tons. So next slide, please. If we had more time, we'd slow this slide down and work through the calculation. But I just do want to show you where the tire load, empty and loaded is. And here's all the numbers. You start plugging in all the numbers and work the calculation all the way down to the bottom where you are calculating the average tire load of 34,785 pounds or 17.4 tons is the average tire load based upon CAT's book values for a quarry body. To calculate the average operational TMPH, we're going to take that load of 17.4 tons, and we're going to multiply that by the average speed we observed in a spot tech study, which was 9.4 miles an hour. That would give us an average operational TMPH of 164. If we wanted to, we could look at the fastest speed travel, which is 11.3 miles, and say the upper range in the fastest time would give us a 197 TMPH. So that gives us some range to play with to help us next to select the right tire. So next slide, please. So here's our product lineup again with all their TMPH ratings. And we see we have an average TMPH of the operation of 164 and with the fastest of 197. And we're just going to assume that in this application, we don't really need a traction pattern. The roads are good. They're not a lot of grade. So we're going to look between the SR47 and SR48 tire. If we look at the cut resistant compound for the SR47, its tire rating is 167, which is only 3 points higher than the average speed for that operation, which is not a lot of buffer. And things go wrong. Trucks get overloaded, tire pressure goes down. So in this case, we would say that to fit this operation, we would probably want to go with a standard compound for this operation. Or if you look at SR48, the SR48 cut-resistant compound at 212 would fit definitely the average and even the fastest. So a cut-resistant compound will give you obviously more cut resistance, but also better wear resistance as well. It's a harder compound, so you'll get more life out of it. So by doing the on-site study, by doing the spot tech study and discussing a lot of things with management, we can now take 17 SKUs and get down to one tire to say the tire that will best impact your productivity, meanwhile giving the longest life, would be the SR48 cut resistant compound in this situation. Next slide, please. And this is the last little bit on air pressure. We have highlighted in the green box 24 to R35. And if you look at the columns, you'll see 102 PSI is 40,800. And that was what we said earlier. That's its rating for a 2-star rated tire at that pressure and load. But we also said that 775G model loaded would actually have 41,905 pounds load on it. If you look to the right, 41,900 requires 109 PSI. So we can say that without even overloading the CAT truck based upon CAT's 10-10-20 rule, that if the truck is loaded perfectly with the target load, the tire will be overloaded, in this case by 1,100 pounds. So instead of using 102 PSI for this tire, the cold recommended pressure should be 109 at best for this tire per the book values. And next slide, please. And when we talk about pressure on tires, especially in the truck and bus world, we're usually talking about wear patterns of contact pressure. But for the sake of TMPH, an underinflated tire is another way of defining it as an overloaded tire and increased deflection. So even if we select the right tire for your operation, if the tire becomes underinflated, then you can generate much more heat and a lot more flex in the tire, that all of a sudden you could experience heat separations, even though the tire itself by calculation should be on there. So again, the pressure compensation helps to offset the T in TMPH for the load, but if it's a fast operation, extra pressure won't help chase speed. So this is a very quick look at a much more involved full day process. Again, our goal is to, back to the goals, the most productive, no extra downtime. We want to have the best wear rates and the best value tire in the operation. And that does require us to come on site and work with you. And we do have that desire to do that. So with that, the formal presentation is ended, and we have time to go to the next slide to be able, again, to look at some follow-up or for questions.
Thanks, Chris. Terrific presentation. Enjoyed learning about all that goes into this. It sounds like there's a lot to choose from if you've got 70 different SKUs alone for a 2400 R35 tire. So there's a lot that goes into choosing the right tire, obviously, with this. Again, if you want to ask questions, send them to tbevents@crane.com. You see on your screen there. Or if you're watching along on LinkedIn, YouTube, or Facebook, use those platforms to send in your questions, and we'll take them in the order that they are received. Chris, let's start with one about your calculations for TMPH, for tons miles per hour. Are all manufacturers' TMPH calculations and ratings the same, or does it differ by who the manufacturer is?
Great question. The calculation that I showed in this presentation is what I would call the bare bones basic calculation of just the load and the speed. And in that aspect, all the manufacturers calculate that portion the same way. So no matter who you're talking to, the basics are the same. That said, every manufacturer does have other revising factors. In some cases, ambient temperature, speeds, haul distances. So the best answer is whatever tire you're looking to choose for your operation, make sure you consult with the tire manufacturer's representation and use their calculation as stated in their data books to calculate it. Because you can use one manufacturer's rating or calculation for another manufacturer, it doesn't work out, and even the rating's a little bit different on how they're rated. So again, always respect the manufacturers on the sidewall and consult with them and use their own calculation.
Okay. So not every manufacturer is the same anyway. So look at what they're doing.
Same but different.
Yeah, exactly. What about tire temperature and pressure monitoring systems, TPMS? Do they help with when you figure out the ton mile per hour, the TMPH, or how does that enter into it?
They can. I'm a huge fan of TPMS. Again, as a tire manufacturer, we want our tires inflated correctly and monitored well. But the good TPMS systems that are out there, the sensors are inside the chamber and are able to report the chamber temperature. And from a tire manufacturer standpoint, once we can start measuring the actual heat buildup directly, then in a lot of ways, TMPH goes out the window. If I had a mine site that was running all their fleet with TPMS, then I would be looking at the actual heat per tire and doing dispatch changes for that. Now, TMPH would still be useful in tire selection to begin with to make sure you're getting the right ballpark. But yes, TPMS to me is the next evolution that TMPH becomes less important, especially in day-to-day operations.
Great. So you see that advancing and changing the industry a little bit in the future.
Absolutely, especially as adoption goes up, and whenever, just like in the passenger world, once TPMS became standard on all the automobiles for pressure monitoring due to NHTSA, again, that evolved. We're not there from a mandate yet in the off-highway side, but once that actually happens, then again, the data available to tire manufacturers and customers and everybody will be much more beneficial.
Excellent. Going back to manufacturers again, are the compounds equivalent in some cases, or is that different too, depending on who the manufacturer is?
Again, within a given manufacturer's product lineup, the standard package you'll see is a heat-resistant tire will always have the highest TMPH rating for that size. Standard is somewhere going to be in between down to the cut. So the harder the compound, the lower the heat capacity of that tire is, and the more heat-resistant, again, the higher rating it will be. So that's within a manufacturer. But when you start comparing even within the same manufacturer, patterns can make a big difference, right? So if you looked at our product slide, patterns with a more open tread face will allow heat to release. So they'll have a different rating. So TMPH rating is a lot of way has to do with compounding and patterns. But if you compared across manufacturers a given size and compound, let's say a standard compound, you will get different ratings between manufacturers, and that's due to compounding sophistication and just how we rate tires. So you do want to be able to, not all cut resistant tires are the same, not all standard compounds are the same. Always look at the manufacturer's rating to make sure and do the calculation, make sure that will also work at your operation.
Great. Again, we only have a couple minutes left, but if you want to ask a question, you can do so at tbevents@crane.com or using your LinkedIn, Facebook, or YouTube platform to ask a question. Chris, you mentioned a bit about heat buildup in tires, and you talked about looking at road conditions both vertically and laterally around the road. Are there any other factors that could impact heat buildup in tires that we haven't talked about?
Absolutely. So, and if you think about the TMPH calculation, it's a truck's distribution on a flat, moving straightforward line. Other factors that can impact and cause more heat that the calculation may miss and cause tires to separate if we don't understand the spot tech side of the operation is, let's say a truck's unevenly loaded. Let's say the load, rather than being center in the bed of the truck, is shifted one side to the other. That side of the vehicle that load is shifted on will put more weight on those tires, which will actually increase, the deflection, the heat buildup. Road camber, the road crown. If the truck's driving along the left-hand side of the road, but yet it's slightly uneven, again, more load shift. Strut maintenance. If the struts aren't properly charged, then rather than the suspension absorbing some extra impact and load, the tires will, which will cause the deflection. Uphill versus downhill loading. If you're downhill loaded, you're going to shift more of that weight distribution towards the front of the tires. We mentioned air pressure. So underinflated tires or overloaded tires, and again, the corners. So over a phone, we can do a quick and dirty by the books math calculation. But until we can get on site and truly understand what's going on, then and only then can we give you the best possible tire for your operation.
Great.
But there are a lot of
Oh yeah, it sounds like it. A lot goes into that. You're looking at road conditions too, and some of the calculations. Is the Spot Tech simulation that you do, is that going to give you quite a bit of data anyway to help you figure out road conditions and what the truck is going to be going on?
Yeah, MSHA, there are standard road engineering calculations for the proper corner radius, or the proper speed and the proper banking. So we will take what we observe and look at what the calculations are and be able to help to look at, is there anything we can do to improve that cornering, if possible, if not, speed limits. So again, we're not here to redesign a customer's haul roads. That's not, they have engineers for that. We're just trying to look at the impacts on tires and see what we can do to work together to, again, just increase productivity and give them the best tire performance possible.
Great. Well, Chris, do you have any parting words or final comments you want to leave the audience with today?
Yeah, no, this was a little bit on the more technical side. I thank everybody for bearing with me on that. If you want to get more in depth on it, please reach out to me. We will be at Mine Expo September 13th through 15th. We'll be in the Central Hall in booth 4457. I will have a monitor and Spot Tech studies going. So any of these things you want to look into deeper, please stop by and let's have a conversation.
Excellent. We can see some of this in action as opposed to online here if you get to the Mining Expo.
Absolutely.
Chris, I want to thank you for a terrific presentation, for taking the time today, and to BKT USA for sponsoring this Ask the Expert session. If you have additional questions for Chris, his email address is on the screen, and he'll be glad to help you with your needs or talk a little bit more about the process and methodology that BKT goes through to address some of the best selection of tires. Today's Ask the Expert session will be available for viewing on the events section of Tire Business's website. So make sure you look at it there, and you'll see more about if you want to review what was discussed today. I'm Joe Pryweller with Tire Business. I'll see you at a future Ask the Expert session, and we'll end with a word from BKT.